Hello, welcome and welcome back to our podcast, Complete Combustion, where we talk about biology and chemistry as a form of A-level revision. So,
Okay, today we're going to be doing some chemistry.
We're doing the amount of substance.
Ooh.
what cool
So like
name.
moles and reacting
More moles.
masses.
Just a lot
More
of calculations.
chemistry.
Okay, right. So the first thing to be aware of in amount of substance is you always have to convert to the units that we need for the question, right?
Always
So
look
mass
at the
is
units.
always in grams in chemistry. So who wants to talk about how we convert to grams?
Well, so I'm terrible at this sort of stuff. Okay, so 1 gram is also equal to 1 kilogram.
Do you want to start off and say, like, if it is given to you in milligrams, how would you make it into grams?
So if it's in milligrams, you divide by 1,000 to get grams. And then if you get it in, in the question, if it's given in kilograms, you'll times by 1,000 to get grams.
Yeah.
And then if you have a ton,
Yes.
you times by
A million.
a million, yeah.
Yeah.
Or 1.1 times
10
10
times.
to
10
the
to the
power
minus
6.
6. Yeah.
So,
And then 1 ton is also equal to 1,000 kilograms, but you could work that out.
when the units get bigger, the number gets smaller, and when the units get smaller, the number gets bigger.
Yeah.
Yeah.
I mean, just a way to keep you accountable in exam situations. It works for me, doesn't work for everyone, but you can try highlight and just make a note before you proceed with the question, so that, because I feel like when you're calculating, you tend to get carried away, and especially in an exam situation where there's a lot of pressure, you can forget
Don't
things like
overcook
conversions.
it. Don't overcook
I
it.
do
Yeah.
that a lot.
Exactly, and then you end up missing a mark, which is incredibly frustrating. So you can just make yourself a note in the beginning, so you can look back and be like, oh, you need to check
It's
if
in
you've done
this,
that or
yeah.
not.
Converting volumes into different units. So,
Volumes confuses me more than the...
Oh no, it's the other way
masses.
around.
I think
Really?
Yeah, for some reason.
the most important thing to remember with volumes is center is 10, as in a tenth. Deci is 10 times that. And then, because it's volume, it's cubed, so centimeters into a meter is 100, so cube it goes to a million.
Whoa.
Yeah, so that's why it's a bit confusing,
I
is
never
because
thought
people
of
think
that.
centimeters cubed. We did do it in maths, darling. We did talk about it with Miss Cox. Okay, so do we want to talk about significant figures, or are we confident we've got that?
I feel like significant
Yeah.
figures is something you cover in like
As long
GCSE
as
too.
long as you as long as you look to make sure in every question, like calculation question, you make sure you look at when you've
And
got
what
your
does
answer.
appropriate significant figures
Usually what I do if it says appropriate significant figures, I look back at the question and see what numbers there are
get?
in the question and see how many decimal places
And then
or
take
significant
the
figures they have.
if there's differences, take the smallest.
yeah,
one.
yeah.
And remember, for significant figures, even if, say it's 2 significant figures and it's 13.45, don't round up the 4 first.
Always round
You always
the last number.
You
At
just
the
look to the
very
next number.
end.
You
Yeah.
do not like round it up then. Okay. Alors.
Okay, moles. Minnie, do you want to do this?
Should I give the definition of a mole?
Yeah, go for it.
A mole is the amount of substance which contains as many elementary particles as there are atoms in exactly 12 grams of carbon-12.
So 1 mole is the amount of substance that contains 6.02 times 10 to the 23 particles.
Otherwise
And
known
that's
as...
Avogadro's constant.
Yeah. So that's the number of particles in each mole of carbon-12. Who wants to say converting numbers of particles into moles?
So
What do we do?
literally all you do is you do like, oh wait, hold on, I'm reading something else. There. Yeah, so moles is equal to like the number of particles times by
Over.
Avogadro's constant, divided by Avogadro's constant.
Yeah.
Yeah.
Good stuff.
Should we talk about
This
molar mass?
molar mass? Yeah. Go for it.
Alright, molar mass. Otherwise known, if you want to need a definition for it, the mass of 1 mole of substance. Units are grams and mole
Per,
to
yeah,
per-
grams per mole.
grams per
And
mole.
it's the same as the MR, so the relative mass.
Yeah.
So for me, I find it a bit confusing when you're given it in grams per mole. Gram
Oh yeah.
gram mole to the
But
minus
it's always
1.
it's always
just the same as
the
MR. Yeah.
yeah. Diatomic molecules.
Yes.
So they exist as like H2, N2,
Have no fear
O2,
of ice cold
F2,
beer.
Cl2.
Basically, the
Br2.
halogens, oxygen and hydrogen.
They always
So
go in pairs.
whenever you like are trying to find like moles or like mass or whatever, when you're using the relative atomic mass, you always times it by 2 because there's 2 of the.
I always forget that when I'm doing hydrogen. I always divide by 1
Same.
when it's 2.
Yeah. Okay, relative atomic mass.
I'll go for that one. The relative atomic mass is the weighted mean mass of an element compared with a 12th mass of an atom of carbon-12. So, and then you have relative molecular mass, which is the mass of a compound compared.
Is the weighted mean mass of a compound relative to the mass of an atom of carbon-12, which has a mass of 12. It might not exist. I might just not have written it because it's pretty. So yeah, we can cut that. And the relative formula mass is the weighted mean mass of a formula unit of a compound compared with a 12th of the mass of an atom of carbon-12. And a formula unit is the simplest ratio of ionic compounds, because obviously it's in a giant ionic lattice. You're not going to go count every single one. It's just the smallest ratio of, like when it's become neutral. Who wants to write percentage mass?
Oh, that's so so when you
Percentage.
calculate the percentage by mass of an element in a compound.
Mhm.
Yeah. So what you would do is, so say you wanted to find copper in copper sulfate, you would divide like the relative atomic mass of the atom of the of the element that you want to find, so copper in this case, divided by the relative atomic mass of the whole compound, and then you times it by 100 because it's a percentage.
Very nice. Very nice. Okay, using moles. So moles, as we know from GCSE or equivalent, is mass over relative atomic mass or formula mass or molecular mass, depending on what type of compound it is. So I think that's it. I feel like we can all rearrange that. I'm not gonna go into.
Yeah, just like put it in a triangle.
Yeah.
Pretty easy to do.
Okay, Minnie, what's the next bit? Nice. Definition, please. Who wants to do it? Mia?
Yeah, if I
For
can find
empirical
it.
formula.
Empirical formula is the simplest whole number ratio of atoms of each element present in a compound.
Yeah.
Very nice.
Do we need
So
to
to
walk
find
through
it
it?
out.
Yeah, I think we should.
It's pretty easy
Okay,
to find
so for OCRA, this is what we've been taught to do. We do a little table, or do you just do it with outlines?
Yeah, I'm not bothering to draw outlines.
Yeah, in an exam. Okay, so at the top you write your elements, and you basically keep it in columns. So in my example, I've got iron and chlorine, and then write the masses, and that's percentage or mass. So if you're given a
Usually-
percentage, you can use that.
When you're
Yeah.
trying to find the empirical formula, like pretty much always you're given, unless it's like following on from another question, you're given the mass because it's like it'll be given as a percentage or something.
Yeah. So, and then you've got your AR, so your relative atomic mass. And then you're going to find out moles in the next column of each, which is just mass or percentage over AR. And then you divide by your smallest number, right?
Yeah. So you can find the ratio of the
And then who wants to say the rules of what we do when we get the ratio? So if it's 1.5 to 2, what do you
just
do?
make sure you can't have decimals basically. You
Yeah,
can't have like
yeah.
So if you have
half a
1.5
number,
and
you
2.
just times it by 2 so that
Yeah.
it turns into
You want
3
whole
and 4.
numbers.
You
if
want
it
whole
is
numbers,
1.9 and 2, what do you do?
yeah. Round up.
Round it, yeah, it's close enough there.
Good stuff.
Test
So,
it.
molecular formula is the actual number of atoms of each element in a molecule. For example, 1 mole of water is made up of 2 moles of hydrogen atoms and 1 mole of oxygen atoms, so it has the formula H2O. What is the factor?
Oh, so this is where if you want to find out like the molecular formula from the empirical formula, and if you're given like the molar mass or the relative atomic mass, you can use the molar mass of the empirical formula, which you'll be given in the question, and you can divide that. No, you'll be given the molar mass of the molecular formula, and you can do the molecular formula molar mass divided by the empirical formula's molar mass, which will give you a factor.
Yeah.
And then that factor basically is
the
whatever. So
timesing,
say it's
yeah.
2, you're going to times whatever the empirical formula is. So like say C5H11, you're going to times that by 2. So it'll be C10H22.
Okay, so it's basically how you get from your empirical formula to the actual molecular formula, which is what you, like, the molecule actually ends up as. Okay? Good stuff.
Alright, my next cue card is on molar gas volume. I don't know what's
I've
going
got
on your
reacting,
guys.
yeah, same. Because there's
That works.
well, there's reacting masses as well, which is like
That's
pretty.
using the
That's pretty
stoichiometric
easy actually.
numbers, which sounds fancy, but it's just the big numbers before
Yeah,
whatever
so it's the
element
ratio of
set.
the moles in the equation you're given, as long as it's balanced.
Also, one thing that I
yeah.
always used to do is when you're finding out like the relative formula mass of like a compound or something, ignore the big numbers. Oh yeah, like just completely ignore the big numbers, because so many people like times like whatever like they found out for the molecular formula, and they times that like they find out the relative formula mass and they times it by the big number. You just ignore them when you find out that.
So moles you ignore. Pretty much everything except...
Reacting masses, and stoichiometry, and reacting volumes and stuff like that, where you're trying to find out the ratio between...
Atom economy. You include it.
Yeah.
That's the word I was looking for. Okay, who wants to do the next bit? I'm not sure where
Minnie,
we're
you
up
do
to.
it if you want now. Yeah, reacting volumes.
Where have you gone?
I don't know, where are we? Mia,
As
what
to
page?
go forward. 22.
Okay, good stuff.
Okay,
You are lovely.
Minnie, you do this.
So, what is molar gas volume? Well, it's the volume per mole of gas molecules at a stated temperature and pressure.
Okay, so at room temperature and pressure, which is about 20 degrees C and 101 kilopascals, one mole of gas molecules 1 mole of gas molecules has a volume of approximately 24 dm cubed per mole, or 24,000 centimeters cubed per mole.
Yeah.
So what can we do with this information?
You can
The
find out the
equations,
moles from the...
which is...
So the moles is equal to the volume divided by the molar gas volume, so basically
stuff.
24 dm cubed mole... dm cubed per mole, or 24,000 centimeters.
Cubed per mole. Yeah,
Yeah.
I remember
I've
to
never seen
always
that.
give the units
Wait,
in these sort of
Esther.
questions.
The computer has done something.
Okay, 1 second, everyone.
Let's give us a moment.
It's still recording.
Please excuse
Is it?
for
Yeah.
the
Okay,
interlude.
good. I just wanted to make sure, because it would be a bit pointless if
A bit
it was-
embarrassing.
Yeah.
No, it's still recording.
That's our
darling.
attentive Mia. Unlike me.
Did you drink your drink?
I did have a bit of a sip.
Okay, so the triangle would be volume at the top and moles and gas volume at the bottom.
Yeah.
Okay, next.
Ideal gas equation.
Oh, I love this,
Let's
if I'm
go.
honest.
This one's actually pretty. Like,
scrumptious.
I don't know if that makes sense, but you do have some
it does.
like equations formulas, whatever, that just look pretty.
It's nice.
They make sense for once.
Okay.
Well, if you think it's
What
so
is
pretty,
it?
then go for it.
PV equals nRT. But what does that mean?
P is pressure, which is in pascals. Make sure to convert from kilopascals to pascals if you're given it.
And volume is in meters cubed, which actually is like quite weird.
It's a
'cause usually-
strange one, yeah.
Yeah. So.
How'd you go? So how many centimeters in a meter?
How many centimeters in a meter? 100. So you.
Cubit is a million.
A million. Yeah.
So if you're going
Wow.
from centimeters cubed to a meter, you divide by a million.
Okay.
That's
You learn something new every day.
N is moles. You could be given it, but you could have to work it out. But that's okay if moles is mass over relative mass.
And then you have
R,
gas constant,
which is
8.314
joules.
moles per something.
I'd like
Yeah.
us to collectively agree that
Moles per
8.314 is really
Kelvin.
lovely
It's
to
nice.
remember.
Yeah.
My teacher told me we don't have to remember it, and
But
it is on the data sheet.
But it
we're
is,
given.
yeah, it is on the data
Which is a
sheet,
bit
so you don't-
annoying.
T,
Kelvin.
temperature in Kelvin. Okay, Celsius to Kelvin. What do we do?
Add 273.
That's such a
Kelvin
weird number.
to Celsius
So each
is minus
each 1
273.
Kelvin rise is the same as 1 Celsius, so that's why you can like do the little conversion thing. And make sure you remember that, because like they don't really explicitly tell you that you need to, but you kind of do.
And always write out the arrangement in your answer, so when you're working it out.
Yeah, so when you, because usually you have to rearrange the equation, well pretty much all the time you have to rearrange the equation, so.
I will make a side note here. It is important that like you sort out your working clearly. Take this from someone who used to have very messy working.
Mine still is.
There are, you know, in an exam situation, you might get unlucky and you might have an examiner who can't be bothered to look through
Look at that.
whatever mess you put on your paper, and you might get a lower mark than you
All over the
deserve.
place.
So save yourself the effort, set out your working clearly for your examiner to look at it and be like, cool, they've gotten so and so marks.
They know what they're doing.
Yeah.
Because you want to prove that you do understand what you're doing and you've not just guessed it. Because you are meant to be proving your knowledge
Exactly.
rather than just going, oh.
And let's be
Popping out an
realistic here.
answer.
If you're an examiner, you're going through hundreds, maybe even thousands
yeah.
of test
You
papers.
can't be bothered to
You
look
are
around
not going to
for
be bothered
answers.
at 7 p.m. on a Wednesday night to look through some students'
Awful.
awful
Yeah.
working. You're just going to be like, okay, well, next.
And it'll be easier for you to check mistakes as well. I think that's another
Exactly.
important thing they don't really mention.
So sort that
Yeah,
out.
good tips.
Mm.
Next
Okay.
bit, reacting
Reacting
solutions.
solutions.
It's just kind of my favourite, if I'm honest. I
Is
love this
it?
equation. It's gorgeous.
Gases are my favourite,
Okay.
personally.
Okay.
So when you're given concentration in moles per dm cubed and volume in centimeters cubed, you can work out moles by doing C, which is concentration, V, which is volume, over 1,000, and then it's just N equals CV when it's dm cubed, but we don't get given it that much.
And concentration, the definition of it, and so the concentration of a solution is the amount of solute in moles dissolved in 1
Decimeter
dm
cubed.
cubed of a solution. My mind just went blank there. And, and the units are moles per
Per
dm
dm cubed. Good stuff.
And also, when usually sometimes in like a question or something like that, they might write concentration a bit differently. So they might like put it in square brackets. So they could put like square brackets around like hydrochloric acid and say, so that basically that means the concentration of hydrochloric acid.
Yeah.
Very nice. So square brackets is concentration.
Right, there's a lot of pages.
Okay, I'm up to standard solutions, dilution, portion effects.
Hey.
Oh, I did not do that. We just completely skipped over it, so you're gonna have to teach it to me.
Right, good stuff.
I'll
So
let
there are
Esther take
two
the
main
lead.
ways of to prepare a standard solution, which is when you're doing titrations. A standard solution is the one you take your samples out of, so that all your titrations have the same concentration, volume, that stuff. So number 1 would be dissolving a solid in distilled water. And number 2 is diluting a known concentration of an existing solution with distilled water. And distilled water, you need it in chemistry because all the ions are taken out of it and it's just H2O by itself.
Which you shouldn't
Okay,
drink.
so the preparation of it, I'm pretty sure we do need to learn. So the preparation would be, you measure the mass using a mass balance, so that is by difference.
Mm-hmm.
And remember, it's mass balance, not scale, because scales measure weight. So, and then you dissolve a small amount of water in a flask, and then you dissolve it in a small amount of water in a flask or a beaker, and transfer to a 250 centimeter cubed volumetric flask, which is just a fancy measuring flask, and you should use a funnel for that because you don't want to spill any acids or alkalis.
Don't want any waste.
So then you rinse the original flask that you've measured into originally with water and transfer the washings to the volumetric flask, because then you've got all of what you've measured in the flask.
Yeah.
Make up to the line at 250 centimeter cubed with water, and you want the bottom of the meniscus, so
What
the
is
dip.
the meniscus?
It's basically the little dip in water you get because of surface tension. Using a dropping pipette, you want to put a stopper in it and you want to invert it to mix it.
Yeah.
So turn it upside down. The second way of doing it would be to use a pipette, transfer the original solution to a new volumetric flask, fill the volumetric flask up to the line that you're trying to measure, how much you want with
your
distilled water. Put the stopper in, invert to mix again. So that's your 2 different ways. In both cases, the number of moles does not change when you dilute with water because the amount of substance is the same inside that. And you can take portions out of the solution, which you're going to use, that's why it's a standard solution.
Yeah.
And then the moles are changing because you are taking a portion out rather than adding more in. I've got some facts that I wrote down here. So for titrations, you want to get concordant results, which means you have 2 results within 0.1 of the same. And make sure you put mass balance and not a scale. Who wants to do the equation?
What's an equation?
This one, the new moles
I
one.
don't have that.
I think it's written at the bottom.
So new moles will equal old moles over your old volume, and you times that by the new volume.
And that is how you convert between your moles in, say, 250 centimeters cubed to the moles in 25 centimeter cubed.
Oh my god.
Hello.
I had a massive realisation.
Yeah.
That's why that never worked in our lessons. Okay. Do you ever use that equation?
Yeah.
Okay.
I use this because my teacher did say, if you know for sure you've got 25 and 250 and you're confident dividing on timesing by 10, but what if you do it the wrong way round? What if you divide when you enter time? So this works because you've got old over new.
Old over old, no?
Old moles over old volume, and then you times it by new volume. You're not going to mess that up because it's just the equation. You're not going to times when you're meant to divide.
Yeah.
Good stuff. Content?
I was thinking moving on to calculating percentage uncertainty.
Or what about percentage purity, darling?
I know, but that's a whole question. We never did that.
Okay, so percentage purity, Minnie, do you want to do it, Minan?
So what is percentage purity? You may be asking. Well,
M is mass, by the way.
The mass of your pure
Yeah.
substance over the mass of the impure substance, and you'll times that by 100 because it's a percentage.
Yeah.
I think most people know that by now.
Oh, I do forget sometimes though, if I'm honest.
Really?
Percentage uncertainty?
Okay. So when you doing a practical, making quantitative measurements in chemistry, there's always a degree of uncertainty. So to find out the percentage uncertainty of something that you're doing, you can use an equation. So percentage uncertainty is equal to the number of readings you take times by the uncertainty on the equipment. They'll always give you that in the question, and divide by the quantity measured, and then times by 100.
Did your class write down how to do the number of readings?
I did, just in my head.
Okay, do you want to say or do you want me to say?
No, you go for it.
Okay, so a pipette always has one reading, and if you measure anything by difference, so then you've got
always
two
two,
readings. So
yeah.
that's a burette because you've got the starting and then the end. Thermometer if you're doing temperature change, and then mass balance, like we said, because that's measuring by difference. Good stuff.
Yeah. Percentage yield?
Yeah. Do you want to say?
How exciting. Percentage yield using moles will equal the actual yield over your theoretical yield times by 100. I feel like this is probably one of the easiest ones out of them all because you'll know if you've messed up. Like if you put the theoretical over the actual, you're
If the
likely to get
actual-
too big of a number.
Yeah.
Because you want it to be less than 100%.
Exactly.
And just a quick note, always make sure in the question, if it says, for like questions like these, if it says by mass or by moles, make sure you have converted to mass or moles,
Yeah.
because that they do give marks for the working. So
And the definition is a measure of how efficiently the reactants are converted into products.
cool.
Nice. I'm assuming we're going to talk about the limiting reagents now.
Yay.
So, if a reactant is not in excess, all moles of it will read. It is the limiting
React.
Is his. Where is
That
the
says-
line in that T? Give me a break.
C.
Give me a break.
T.
Do you see a gap there?
Yes.
No. Do you see a gap there?
Yes.
Kind of, yeah.
Shush.
Yeah.
Actually, shush.
Okay, anyways, continue.
I'm short-sighted,
If a
okay?
reactant
So
is not in
am I.
excess, all moles of it,
Will react contrary to what this paper says in front of me.
and therefore it is the
Limiting
limiting reagent.
It'll be used up completely, which will determine the amount of product or products made.
Good stuff. Do you have anything else to say, Mia?
Like all the calculations that you make like afterwards, like if you're finding the moles or like the mass or something, you don't use the thing that's in excess, you use the limiting reagent.
Because that's going to be what's actually made.
Yeah.
And in chemistry, you want to be
Yeah.
accurate to what's actually happening rather than what's theoretically happening.
Okay. Atom economy?
Yeah, who wants to say?
Me.
Go for it.
Okay. The atom economy of a chemical reaction is a measure of how well atoms have been utilised.
Mm-hmm.
So the equation for it is the percentage of atom economy is equal to the sum of the molar masses of the desired products, and they'll give you what product they want in the question, divided by the sum of the molar masses of all the products times by 100. And when you say molar mass, it's just like the MR, the relative formula mass.
Remember to include your coefficients with atom economy.
And this is the only equation where you actually do need it.
Mm.
And atom economy is a measure of how much waste product in a reaction produces.
And you
Good
want
stuff.
as little waste as possible.
Yeah.
Should we touch upon sustainability? Or
Yeah, go for it.
You know, I did not even know that was there.
Slice?
It looks like it just looks a bit not nice. Okay, so sustainability. Modern sustainability requires industries to operate processes with high atom economies, so you've got less waste products and fewer pollutants. So using fewer fossil fuels lowers CO2 emissions,
That's a lot
which
of
should
Fs.
reduce global warming. So, for example, if you've got a higher percentage yield, so therefore you don't have to heat up your reaction as much to repeat it to get what you're aiming for, then you're using fewer fossil fuels. Addition reactions have atom economies of 100% because you've got your two reactants, they just add together to make your product.
Yeah.
As the desired compound is, as only the desired compound is formed and there's no byproducts, there's no wastage. Remember that the percentage yields and percentage atom economy are not the same. A reaction can have a high percentage yield and a low atom economy, and the efficiency of a process depends on both, because in my mind, atom economy is like the balanced equation, and then percentage yield is more like in practice. Sharing facts. Mia has one this week. What do you
I
want to
do.
share, darling?
I have many.
Okay.
Well, pick
Was
pick
it?
one
It was.
or
It was
two.
mental health like week last week.
Okay.
Indeed, it
So
was.
we did like a quiz in form, and I don't know whether these are shocking, but they're more like kind of like they
You-
kind of bring
yeah.
like a bit of like
It's a reality check.
yeah,
Yeah.
that's what I was looking for. So apparently, like prisoners, like apparently like 90% of prisoners suffer from mental health issues when they're in prison. And we were having this massive debate about this in the forum. We were talking about like how maybe is it like that prisoners they'd suffer from the issues when they first gained them when they went into prison, and because of the treatment that they have like in the prison system, that's what made them suffer. Or is it because that like a lot of prisoners and people who
They might be guilty.
like criminals, it
Yeah.
could be guilt, it could be like because they've had like a bad upbringing and they've had suffered through a lot of
Yeah.
trauma, and they've kind of like stopped and like thought in prison because there's nothing really that they can do, and it's like they just had to be like a reality check and just like so
That's
yeah.
so cool. I might link your fact to my fact. I was gonna do a different fact, but you reminded me of like something we're learning about in psychology, because your girl takes A-level psychology. And one of the like experiments / studies we have to learn is the Stanford Prison Experiment, which I think I talked
Yeah, you
to you
did.
about. But basically, the leading researcher, Philip Zimbardo, he wanted to test whether it was dispositional factors that led to
Dispositional.
within us.
Okay.
So, or was it situational? So was it the situation which caused, prison violence and like the hard environment prisons are
Yeah.
for prisoners? Like, is it the guards who, like, are we just unlucky and we just end up getting more hostile, brutal people in those jobs? Or is it the
the jobs
situation
themselves?
that's
Yeah.
causing them to behave that way? It was a test, and they found that the volunteers, they used a volunteer sample for this, they used male students. They found that the male students who were randomly allocated as prisoners, even though like they all knew each other's names and they knew they were entering like an experiment, they knew it wasn't real. One of the findings was that 90% of their conversations were just about their prison life. Like, they didn't talk about anything else. And they were found to have been showing signs of withdrawal as well. Like, they really conformed to their roles. Which, you might think, oh, that's, they were just behaving as they would. But I feel like you don't think that you'll behave that way, because when you walk in, it's like, you know who you are. You know you haven't done anything. Like, none of these students had committed a crime, but they acted like prisoners
It's kind of like
because of the situation.
it's that you're losing your freedom, so I guess you're also losing like a part of you, like your identity as well.
Yeah,
So yeah.
it's peculiar, because you'd think, well, it's not real. It's temporary. So you'd think that they were getting paid as well. So I think a lot of them went in just being like, okay, well, it's the summer, I'm just going to participate, learn something new, get some money and go. But it showed some concerning results, that experiment. Okay, well, you?
I have 2 quick facts. Number 1, if you train pigeons, I love this fact. If you train pigeons for 2 weeks and you give them pictures of like microscope slides from biopsies of cancers, they can diagnose like whether it's metastasized or is benign with 90% accuracy, which is the same as a pathologist who's trained for 7, like however many years.
Oh my god.
I have a question. How do the pigeons diagnose? Like, do they
Okay,
see the
so
photo and they just
basically-
flap onto the head of
Right,
like,
basically.
cancer?
They're in like a box and they get shown pictures like on either side of these cancers, and they peck at the one which is like metastasized,
Oh my
and it was
goodness.
90%.
Do they know how they tell? Like how they know?
No, it's because they train them to like recognize visually.
This
Oh.
equals
So
this.
they
like,
can
can-
visually recognize and see, like, understand microscope slides.
That's
That's cool.
So there was one pigeon who was going all awry, so it like fell down like the percentage loads. When they took out that anomaly,
That pigeon.
that anomalous pigeon, it rose to 90%.
I love
Okay, so
that.
that's my first fact.
The
my
anomalous
second,
pigeon.
my second fact is that if you play classical music in a supermarket, that is the type of music that is most likely to get you to spend money.
Really?
And if you play, I feel like we know this, but slower music makes you slop
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 around in the shop.
slower. And then you want slower music when you're driving as well, like I said to you.
Uh-huh.
Slow music when you're driving helps you to drive safer.
So don't listen to the Mario Kart soundtrack when you're
Yeah.
driving.
Bit dangerous.
Nice.